Good morning to everyone. This is Debasis Mohanty. Once again, I am welcoming to you all to our chapter polynomial. And in the last days, we have already done the discussion of our polynomial term. What do we mean by polynomial? Then after, depending upon the degree, how to classify. All these things we are already discussed in our last days. So today we will do the discussion how to find the zero of a polynomial. How to find the zero of a polynomial. Understood and not understood? But before going to the perfect point discussion, few of the extra thing it will be required, so through which we can do the discussion such that directly indirectly we can describe the zero of a polynomial. Okay, so first I want to show you one of the polynomial, and the polynomial it is px, it is equal to x square plus 2x plus 1. It means our polynomial, it is our x square plus 2x plus 1. Suppose I will say to you, you just have to replace the x by putting 1. Where you are getting the x in the polynomial, in that x, in the place of that x, you just have to put it as the 1. So then after, your polynomial becomes 1 square plus 2 into 1 plus 1, which is equal to 1 square means 1 plus 2 into 1 equal to 2 plus 1, which is equal to 4. So this one it is called as the value of the polynomial px at x is equal to 1. You have already learned in our standard 9. You have already learned that whenever you will put the value in the place of the variable, so how much the result you got, always that one it is called as the value of the polynomial at the value of the x is equal to 1, otherwise at x equal to 2. So for which on putting x is equal to 1, we got it as the polynomial it is equal to 4. So for which that result we can call it as the value of the polynomial at x is equal to 1. Otherwise we can call p of 1, it means p within the bracket it is 1, which is equal to 4. Also it means p at x is equal to 1, it is equal to 4. Understood? So now one of the example I am showing, okay, so by seeing you just have to say one of the linear example, linear polynomial I am showing, and that polynomial it is our px is equal to x minus 1. Whenever I am putting in place of x, I am putting it as the 1, the polynomial becomes p of 1 equal to 1 minus 1 is equal to 0. So on putting the value of the x, when we are getting the polynomial becomes 0, then after that value of the variable, we will call it as the 0 of the polynomial. So 0 of the polynomial means the value of the variable for which we will put it in the polynomial such that the polynomial becomes 0. So here on putting x is equal to 1, we got the polynomial becomes 0. So for which 1 is called as the 0 of this linear polynomial. Here another example I am showing, which is of our quadratic polynomial, and the polynomial it is px is equal to x square minus 1. On putting x is equal to minus 1, so p of minus 1 becomes minus 1 square minus 1, which becomes 0, and p of 1 is equal to 1 square minus 1, which is equal to 0. So it means for x is equal to 1, the value of the polynomial becomes 0, and for x is equal to minus 1, also the value of the polynomial becomes 0. So it means this quadratic polynomial has two zeros. One it is 1, another one it is minus 1. You just have to remember one of the extra thing, linear polynomial as the degree it is 1, so for which here it is the number of a 0 it is 1, and as it is the quadratic polynomial degree 2, so for which it has the two zeros. May these two zeros may be equal, may be different, but it has the two zero, linear having the unique zero, otherwise single zero. Understood and not understood? In both the cases, so in the linear polynomial we got it as the 1 is the 0, and in the quadratic polynomial we got it as the 1 and minus 1 it becomes 0, but this one we got after putting the value in the polynomial. It means it is called as your trial and error method. So first we will put 1, 2, 3, 4, 5. Wherever we are getting the value of the polynomial, it is equal to 0 on for which value of the variable. So that value we will call it as the 0 of the polynomial, which is much more time taking. Trial and error method. One fails, then after another we have to put, just like we have to continue the process. So for which the easier method, it was said to you how to find out the 0 of the polynomial. It was always you have to just equate the polynomial it into 0. Just equate the polynomial it into 0. From that equation you can find out the value of the variable. Okay, which questions we have already done on behalf of the same question. Once again I am doing with the proper step how to find out the 0 of the polynomial with the proper formulae. Our trick is, suppose one of the polynomial it is px is equal to x minus 1, and it is asked that you have to find out the 0 of the polynomial. So to get the 0 of the polynomial, we just have to equate the polynomial with the 0. So it means px we need to equate with 0. So polynomial becomes 0. So polynomial means x minus 1 is equal to 0. On equating x minus 1 is equal to 0, it implies x, it is our 1. How much the value of the x you are obtaining from by solving the equation, that value of the x, it is called as the 0 of the polynomial. Also previously also the same value we got, that one it is the 0 of the polynomial. And in the second one, it is the quadratic one I am showing, where the polynomial it is our x square minus 1, and x square minus 1 it is equal to 0. Whenever we will equate the polynomial it into 0, so that we can find out the 0 of the polynomial. So in the first step, I just equated x square minus 1 to 0. On equating equal to 0, as it is the quadratic, always the formula is you just have to factorize the polynomial. Quadratic polynomial you just have to factorize. On factorizing x square minus 1, it becomes x minus 1 whole into x plus 1, which is equal to 0. Acha, x minus 1 and x plus 1, their product it is equal to 0. It means either this one it will be 0, otherwise this one it will be 0. So for which either x minus becomes 0, otherwise x plus equal to 0. Whenever x minus equal to 0, it means at that time x becomes 1. X minus equal to 1, on equating you will get it as the x is equal to 1, and whenever the x plus 1 is equal to 0, on solving you will get it as the x is equal to minus 1. So it means here you are getting the two zeros, one it is our x is equal to 1 and another one it is our x is equal to minus 1. Okay, so now I am showing you one of the general polynomial and how to find out its 0. I am showing you the general polynomial, means the standard form of the linear polynomial, which is equal to x plus b. Our standard form of the linear polynomial of one variable, it is our ax plus b. Polynomial px is equal to ax plus b. So how to find out the 0 of the general form of the polynomial? So which is equal to our formula is that polynomial you just have to equate to the 0. So that polynomial means ax plus b, I am equating it with the 0. On equating I got it as the ax is equal to minus b, and next step it is x is equal to minus b by a. So minus b by a means actually in the polynomial b is the constant and a is the coefficient of x. Once again repeating, actually we got the 0 of the standard form, otherwise general form of the polynomial it is x plus b. We got the 0 it as the minus b by a. Actually minus b by a means minus b means constant term of the polynomial and a means coefficient of x. Always the same formula you can apply whenever you are solving to get the 0 of any of the linear polynomial. So the formula is minus b divided by a minus constant term of the linear polynomial divided by coefficient of the variable x, otherwise y, otherwise anything. Is it clear to everyone? Everyone understood, I hope. Okay, so here we got the 0 of the linear polynomial in the term of the constant and coefficient of the polynomial. So here it is called as the relation of the 0 with the coefficient of the x. So in the same way, In the same way we will do, and in the coming class we will do the discussion how to find out the zero of a quadratic polynomial and how to formulate one of the relation between the zero of the quadratic polynomial with the coefficient and constant of that quadratic polynomial. Understood or not understood? So now I want to show you the graphical representation of our polynomial, which is not not much more discussion it will be required. Only just normally we will do the discussion graphical representation of the polynomial. So first we will do the graphical representation of the linear polynomial. Graphical representation of the linear polynomial, and whatever the zero of the linear polynomial we got, actually what is the real meaning whenever we are plotting the graph of a linear polynomial. In the graphical representation of the linear polynomial, where we are getting the value of the zero of the polynomial. It is the important thing you just have to remember. Okay, so one of the linear polynomial example I am showing, y is equal to 2x plus 3, and you know that very well. In the y is equal to 2x plus 3, it means it is in the form of ax plus b. Here a it is 2 and b is equal to 3. And you know very well to plot a graph. Here it will be x coordinate required and it will be the y coordinate it will be required. So for which we are putting the value of the x and we are getting the value of y. So here for the value x is equal to minus 2, we got it as the value of the y, it is minus 1. And another one it is whenever we took the value of x is equal to 2, once again we got the value of y is equal to 7. It means two different point we got. One point it is our minus 2 minus 1, another point it is our 2 and 7. As you everyone knows that the graphical representation of a linear polynomial, it is always line, and to construct a line only 2 points it is required, and we have already got the 2 points in the coordinates form. One it is minus 2 minus 1, another one it is 2 and 7. So on the graph paper, whenever we will plot its structure, it will be just like this. You can see in the picture. In the picture, it is clearly seen that the picture it is intersecting the x-axis at the point of minus 3 by 2, comma 0. So it intersects the x-axis at the point of minus 3 by 2, comma 0. Actually, here it is minus 3 by 2 means actually minus 3 by 2. Otherwise, where the line intersect the x-axis, its x coordinate it is our minus 3 by 2, and minus 3 by 2 it is not other than our zero of the polynomial. Actually our zero of the polynomial in the linear polynomial, it is minus b by a. Actually zero of the linear polynomial, it is minus b by a. So here it is b it is 3 and a it is 2. So for which the zero of the linear polynomial, it is our minus 3 by 2. But here we are getting in the graphical representation, actually minus 3 by 2, it is the point on the x-axis where the line intersect the x-axis. So zero of the polynomial, it is no other than where the linear graph intersect the x-axis. Clear? Zero of the polynomial means where our linear graph intersect the x-axis, it is called as our zero of the polynomial. Zero of the polynomial means at that point the line intersect the x-axis. Clear? Everyone understood perfectly? Everyone perfectly understood? So now I just want to show you the graphical representation of a quadratic polynomial. Actually, how to plot the graphical representation of the quadratic polynomial. Actually, it will not be asked in the exam, otherwise it is not in your course that you just have to plot, otherwise do anything. But whenever you will plot by taking the different points of the quadratic polynomial, actually the structure of the quadratic polynomial, it will be in the form of just like this. See the picture, either it will be open upwardly, otherwise it will be open downwardly. Understood or not understood? And this type of structure we can call it as the parabola. Graphical representation of the linear polynomial, it is our line. Remember, many times it comes. Graphical representation of a linear polynomial, it is our line. But the graphical representation of a quadratic polynomial, it is our parabola. Whenever I will say anyone, here it is the student. Student means girl students. or boy students? So in the same way, parabola means parabola are of two types. Parabola are of two varieties. Okay. So one it is, see the picture, one it is our opens upwardly and another one it is opens downwardly. Ready? So here it is the question, it comes that how we can say which parabola its graphical representation opens upwardly and which one graphical representation open downwardly. Remember, our standard form of the quadratic polynomial, it is our ax square plus bx plus c. Remember, a is the coefficient of x square, b is the coefficient of x, and c is the constant term. Only you need to check the coefficient of x square of that polynomial. Coefficient of x square means a, in the standard form ax square. So a is the coefficient of the x square in the quadratic polynomial, which is in the standard form. If a is greater than 0, if a is greater than 0, then the parabola open upwardly. If the value of the a it is less than 0, then the parabola opens downwardly. How is it? Opens upwardly whenever a is greater than 0, opens downwardly whenever a is less than 0. It is easy or difficult? Understood or not understood? So you can say me easily, quadratic polynomial means its structure it is parabola. But a parabola upwardly open, otherwise downwardly open. How you can say? By checking the value of the a. Polynomials, its coefficient of the x square. Coefficient of the x square you have to check, and you just have to say to me that whether it opens upwardly, otherwise it opens downwardly. Ready? Perfectly understood? Then after open upwardly, it means also it is of three varieties. Okay. Opens upwardly, it means it is of three varieties. See, the figures are three varieties. In one figure, the parabola intersect the x-axis at two different points. See perfectly in the figure. In one figure, it intersect the parabola upwardly opens, it intersect the x-axis at two different points. In another figure, that parabola touch the x-axis at a single point. Previously, intersect the x-axis at two different points. Here intersect the x-axis, otherwise it touches the x-axis at a point. Another one it is does not touch the x-axis. Understood or not understood? Remember, when it intersect at two different points of the x-axis, remember, on solving the quadratic polynomial, whenever you are getting two different zeros, when you are getting two different zeros, so it means its graphical representation, it will be parabola intersect the x-axis at two different points. Two different zeros for which intersect the x-axis at two different points. Whatever the quadratic polynomial we are discussing now, where a is greater than 0, opens upwardly. Okay? And whenever we are getting the quadratic polynomial, their zeros are equal 0. Two zeros, but two zeros are equal. 1, 1, 2, 2, 3, 3. Quadratic polynomials means 100% you will get the two zeros. Okay, either the two are equal, otherwise two are different. Whenever different, you are getting the figure where it intersects the x-axis at two different points. Whenever you are getting that it touches the x-axis at a point, so it means it has two zeros, but the two zeros are equal. Otherwise, you can say it as it has single zeros. Okay. Whenever the two zeros are equal, it means the structure it will be just like this. The graph it touches the curve touches the x-axis at a point. And whenever you are not getting any real value for the zero of the polynomial, whenever you are not getting any of the real value for the zero of the polynomial, you are not getting any real value, zero of the polynomial either 2, otherwise 1, means both are equal, otherwise you will not get any real value of the zero of the polynomial. So in that case the situation it will be just like this, it opens but does not touch the x-axis. Clear? Perfectly understood? Okay. Then another way I am showing. Here it is opens downwardly. Also the situation it is same. Opens downwardly, it means A it is our less than 0. A it is less than 0 means opens downwardly. But downwardly also means 3 situation comes. In one situation downwardly opens downwardly but intersect the x-axis at 2 points. And another one it is touches the x-axis at a point. Another one it is does not touch the x-axis. Okay, so whenever A is less than 0 and it has 2 different zeros, the situation it will be it intersect the x-axis at 2 different points. Whenever A is less than 0, all these things are we are doing the discussion only for the less than 0. Whenever A is less than 0 and both the zeros are equal, then the structure it will be just like this. It means the curve just touches the x-axis at a point, Ready? Single point means 2 zeros are equal. Thereafter last figure does not touch the x-axis. It means there is no real zeros are there. The quadratic polynomial having no real zero for which it does not touch the x-axis. Clear? Otherwise another easy trick I am saying. Listen, by factorizing the polynomial also you can say which one it will be for which figure. The polynomial, its graphical representation it will be our which one. See, whenever on factorizing the quadratic polynomial, remember actually if the polynomial having A is equal to 0, it means opens upwardly, otherwise opens downwardly. Both the things we are clear. That one you have to check, open upwardly, otherwise opens downwardly by checking the coefficient of x square, otherwise by checking the value of the A. Then after remember, on factorizing, if you are getting that the two different factors, on factorizing the polynomial, if you are getting two different factors, it means our polynomial intersect the x-axis at two different points. If on factorizing we got that the polynomial having two equal factors, it means it touches the x-axis at a point. And whenever you are unable to factorize, otherwise whenever its factorization it is not possible, so for that situation it does not touches the x-axis. Everyone clear? Otherwise another formula it is also there. Remember one value, that one it is called as a discriminant D. What it is? Discriminant D. By checking the discriminant D, also you can say whether the graph intersect the x-axis at 2 point, otherwise 1 point, otherwise does not intersect. See, remember the value of a D is b square minus 4ac. B square you know, ax square plus bx plus c. B means coefficient of x and c means constant, and a means the coefficient of x square of the polynomial. Polynomial it is in the form of ax square plus bx plus c. It means a is the coefficient of x square, b is the coefficient of x, and c is the constant term. It means a, b, c already known. So it means our discriminant D you can find. The value of the discriminant it is b square minus 4ac. B square minus 4ac you can check. B square minus 4ac if its value is greater than 0. If b square minus 4ac value greater than 0, then after it intersect the x-axis at two different points. B square minus 4ac greater than 0. Ready? If b square minus 4ac is equal to 0, if b square minus 4ac is equal to 0, it means it touches the x-axis at a point. Ready? And last one is if b square minus 4ac is less than 0, if b square minus 4ac is less than 0, then after the curve does not touch the x-axis. Perfectly understood. B square minus 4ac greater than 0, it means touches the x-axis, otherwise intersect the x-axis at 2 points. Greater than 0, intersect at 2 points. Is equal to 0, b square minus 4ac equal to 0, it touches the x-axis at a point. And if it is less than 0, it does not touch the x-axis. Perfectly understood? Perfectly understood? Understood and not understood? Okay. Then after another term, that term is, just see the figure. Just see the figure. In the two figures where you are getting the downwardly bottom point, this blue color point, it is called as our vertex. Also, whenever it will be open upwardly, the below this point, it is called as our vertex, and whenever downwardly opens, also the above tip point, it is called as our vertex. Here it is a downwardly bottom point, it is called as your vertex. Otherwise opens downwardly, also the top point, it is called as our vertex. Remember that whenever anyone is asking how to find out the point of the vertex, it is how much. Remember the formula of the point of the vertex formula. Remember, it is important thing. That one, it is the coordinates are x coordinate, it is our minus b by 2a. B, ABC you know already from the quadratic polynomial. ABC, it is already well defined. So it means how to find out the x coordinate of the vertex. X coordinate of the vertex is minus b divided by 2a. And y coordinate of the vertex is minus d divided by 4a. Minus d divided by 4a. D means b square minus 4ac. Clear? Shortcutly you can find it is comes many a times, it comes in the objective type question. Find out the vertex of the polynomial. Vertex of the polynomial points are x coordinate minus b by 2a and y coordinates it is minus d discriminant divided by 4a. Okay, I hope everyone understood everything. So now we will do the question number 1 of our first exercise. Exercise 2.1. Everyone, you just have to see the first question. See, here it is given that here it is the graphical representation of the polynomial y is equal to px, it is given. So you have to just say, by seeing the graphical representation, its curve, otherwise the polynomial, how many having how many x intersects, having how many zeros. From the figure it is given that how many zeros the polynomial has. The polynomial having how many zeros, you just have to see the graphical representation and you just have to say to me. Everyone see in the first figure. In the first figure, the graph, it is the curve, it is straight. It does not touch the x-axis. So for which this polynomial having no zeros, otherwise zero zeros. No zeros is there. Second figure, you just have to see in the second picture, the curve intersect the x-axis at a single point. So for which the polynomial having single zero, otherwise 1 0. Another figure you just have to see in the third I question. In the third I question, the curve intersect the x-axis at 3 different points, 3 points. So for which the polynomial, for which the graphical representation it is just like this, that polynomial must have 3 zeros. Ready? Another figure you just have to see in the question number IV, it is given. So the curve intersect the x-axis at 2 different points. So for which the polynomial whose graphical representation it is question number IV, that polynomial must have 2 zeros. Another question number 4, here it is the graphical representation of one of the polynomial it is given, and the curve intersect the x-axis at 4 different points. It intersects the x-axis at 4 different points. So for which the polynomial whose graphical representation is this one, that polynomial must have 4 zeros. Understood? Now it is in the last question, question number 1. Here it is the VI question. See, in the VI question, in the graphical representation, the curve touches the x-axis at 1, 2, 3 points. At 3 points. So for which the polynomial whose graphical representation it is question number VI, that polynomial must have 3 zeros. Clear? Perfectly understood. By seeing the graphical representation, you can easily say that the polynomial must have how many number of zeros. I hope you all understood everything on the today discussion, and whatever the important thing also I said to you, all these things you have to make it in your note. Okay, you have to write it in your note. Okay, and in the coming days we will do the discussion between the relation of the zeros, relation between the zeros of the quadratic polynomial with the coefficient of the polynomial. Okay, thank you, have a nice day.